Hi all, good morning, how are you? Welcome to the virtual learning. Today I'll start the chapter Linear Programming. This is the 12th chapter in your Part B textbook and the board weightage for this chapter is 6 marks. I started the reason for starting with this chapter is this is very easy to understand and you'll be able to complete all the tasks very easily. Now the linear programming is very much important in real life situations. This is one of the main branches of mathematics, which is also called as optimization method or optimization technique. Linear programming chapter is applicable in real life situations. For example, if the builder has to construct a building, so what do you think his objective would be? His objective is to get a maximum profit by giving the best product. So for this process, he has some limitations. What are the limitations? So he has to meet his budget. He has to spend the money for constructing material, for construction material, for the labor work and all the other things below his budget. This is called as the limitations. So with all these limitations, he will plan how he can get a maximum profit. This is exactly called as the optimization method. How does he optimize to get a maximum profit, maximum benefit out of it? So this is the chapter linear programming. Linear programming, almost nothing is new to you. It is almost related to what you have done in linear inequalities in grade 11. So the extension of linear inequalities is after the graphing part. There are some new terminology, some new terms related to this chapter. You have to figure out that and then see how do we get a maximum profit out of it. So there are some word problems in this chapter that I will explain in the next video. But first I will show you what are the limitations, how does we get a maximum or minimum value out of these limitations. So for this I will take one example, one problem and I will show you on the board. Okay, now I will show you the problem. So linear programming 6 marks, this is how you get a problem. Minimize the objective function subject to, these are the constraints given, x plus 2y less than or equal to 8, 3x plus 2y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 0. So these are called as the constraints. So these are called constraints or limitations. Under these limitations, how do we minimize this function? That's the question. This is called as objective function, as this is what we are trying to minimize. Now these constraints, first we will draw the graph of these constraints. Since x is positive and y is positive, we will take the graph only in the first quadrant. So now coming to the other two constraints. The first one, x plus 2y less than or equal to 8. Let's take x plus 2y equals to 8. How do you draw the graph? Change it into the intercept form. Divide by the same constant on both sides. So this is x by 8 plus 2y by 8 is y by 4 equals to 1. So here the meaning is x-intercept on x-axis, this line intersects at 8 and on y-axis at 4. Same way for the second equations, divide by 12 with both sides. Divide with 12 on both sides. So x-intercept is 4, y-intercept is 6. Now how do you draw the graph of these two equations? Now suppose this is the first quadrant. This is origin, positive x-axis, positive y-axis. So for the first line, since x-intercept is 8 and y-intercept is 4, mark them and join these 2 points. Same way for the second constraint, since x-intercept is 4 and y-intercept is 6, join these 2 points, you will get the second constraints. Now these are less than. Less than means below the lines. So both are like less than 8, less than 12. So equal to is this, less than is below this. X positive this, y positive this. So under these 4 constraints, you got a closed region. This is the one constraint, this is one constraint, this is one, this is one. So this is like walled off, closed region, so or bounded region, or the other terminology for this is feasible region. Got it? Now this is the feasible region. So in this, all the coordinates on this are the solutions for these. So all these points are satisfying the constraints. So all are the solutions. But our objective is to find the minimum, least one, which out of all these solutions, which is the least one. Okay. To find that, obviously the minimum or the maximum lies at the boundaries, corners. So where are the corners? Corners are points of intersection of two lines. So here we have for this is one corner O, and here this is one corner which is point of intersection of these two, which is marked as A. This is one corner where two lines are intersecting, point B, and this is the fourth corner point. So altogether on this boundary we have 4 points which are called as the corner points: O, A, B, C. Okay, O, A, B, C. Now what are these corner points? O is 0, 0, we know that, but A is a point on x-axis. So it is x value 4, 4, 0. And C is on y-axis, obviously this is 0, 4. Now how about B? B is the point of intersection of these two lines. Now you remember how do we find the point of intersection of two lines? So, sorry, x plus 2y is equal to 8 and 3x plus 2y is equal to 12. So to solve these two line equations, okay, by elimination method, I have multiplied by 3 the first constraint on both sides and I have solved the two equations. So 3x gets cancelled, 2y minus 6y minus 4y, so y is equal to 3. And from here I got x value is 2. So with this the corner point B is 2, 3. Now once we get all the 4 corner points, take a table. This is the objective function. 4 corner points. Substitute each coordinate in the objective function. Out of all the 4 values after substituting, you got 0 as the least value, then 6, then 12, minus 12, then 16. Tell me which is the least value out of these 4. Minus 12 is the least value. So that means we are getting a minimum value of minus 12 at the corner point 4, 0. So minimize the objective function, yani the objective function minimum value is minus 12 when the variables are x and y are 4, 0. This is how we will find the minimum value. Same way, if the question is maximized, we would have found the maximum value out of this. Tell me what is the maximum value? 16. At what point? 0, 4. So the objective function is maximum at 0, 4 and the objective function is minimum at 4, 0. This is how we find the optimization of the linear programming. Got it?